Grant, Vojta, and McKinsey, and we did our project on manufacturing of composite skis.
This is an overview and application of skis. The first mention of skis was in 7000 BCE in Russia and other Scandinavian countries. They were mainly used for making travel on snow easier for transport, hunting, and military maneuvers. Early skis were made out of pure, straight pieces of wood. Now it's cambered, laminated, or sandwich composites. And then there's two main uses of skis, alpine skiing and Nordic skiing. Alpine skiing is the downhill runs with assisted transport uphill, where the heel is usually fixed, and Nordic skiing is more variety for like cross country skiing or ski jumping, and the heel tends to be free to facilitate movement. So these are the performance requirements. Harsh conditions mean the requirements have to be pretty high. Temperatures of repeated freezing, water and humidity, so no water soluble materials, and there is a risk of corrosion. High velocities, up to 160 kilometers per hour, a lot of mechanical loads, human weight, high pressures due to small contact area, repeated bending, shock absorption, and impact resistance. The lifetime of skis is about 100 to 150 days or 8 to 10 years, but it depends on many factors. And the price depends, but skis can be both engineering and advanced composites.
Each ski is made out of 5 main components. Each component has its own functionality, which will determine the material selected for the application. The core is for flexibility and strength and can be made out of wood or a combination of wood, foam, metal, or fiberglass. The structural layers protect the core and also add additional flexibility and torsional strength. The carbon fiber and fiberglass are commonly used, but titanium aluminum alloys are used for more advanced composites. The top sheet and base provide mostly aesthetic function, but it also provides environmental protection. Fiberglass and nylon are used for the top sheet, and polyethylene plastic or PTEX is used for the base. The sidewalls are made from TPU, ABS, or other ultra-high molecular weight plastics. They are used for edge control for turning, as well as moisture resistance to protect the core and structural layers. Phenolics have been used for more expensive ski builds as they provide better bonding between layers. And finally, the edges are used for grips for turning, and they're mostly made out of steel. Each layer of the ski is responsible for different properties, and the ideal combination minimizes weight and maximizes mechanical properties. The core needs to withstand torsion, so wooden cores are pre-laminated and denser fiber woods are used. The structural layers provide stiffness, so woven fabrics are used because they align fibers longitudinally. Epoxy is also added to the fibers. The top sheet and base must be waterproof and impact resistant, and to achieve this, hydrocarbon wax is used. The sidewalls can be constructed using sandwich or cap construction, which is shown in the top right-hand corner. Phenolic sidewalls also are used to encourage bonding between layers, and rubber layers are also used as intermediate layers to increase bonding and increase damping within the skis.
For manufacturing composite skis is a wet layup sandwich method. Each layer is laid down and wet laid up with a epoxy resin, and then repeated that step until all the layers are on the sheet, and then the ski is sent to a ski press where pressure and heat are used to compress the ski together until the resin is cured. The ski is then taken out of the press and is called cut out of the board, so they cut the shape out of the board for the ski, and then finally post-processing happens where there's a nice finish put onto the ski and chamfered the edges to allow it to have a good finish. Skis are inspected through a visual test of looking for any damage or dry spots in the resin, and also they're characterized by an on-snow testing by a skier who then assesses the feel of the ski. Currently, there are new technologies to test the torsional and bending of the ski and laser profile of all the dimensions of the ski. Skis cost a lot of money, however, they do not cost that much to produce each ski. The major contributing factor to the cost of skis is the material cost and then capital investment and labor.